Hello and welcome to 6.3 Notes. Okay, let's start off with this following definition. Two polygons are said to be similar polygons if corresponding angles are congruent and corresponding side lengths are proportional. So again, if the corresponding angles are the same measure or if they're congruent, and if the corresponding side lengths are proportional, then the figures are said to be similar polygons. Okay, they're said to be similar. So in these two figures, polygon ABCD is said to be similar to EFGH. So what that must mean is that angle A is going to be congruent with angle E. Angle B is going to be congruent with angle F. Angle C is going to be congruent to angle G. And angle D is going to be congruent with angle H, which is what that says there. And please keep in mind that the order in which you travel around the figure and also the order in which you travel around the letters is very important. So over here, give me a moment here. Over here, remember you have the first letter is going to be congruent with the first letter. That's why angle A is congruent to angle E. First and first. Also second and second are congruent. Third and third are congruent. Last and last are congruent. So the order in which you travel around the letters is important. So here's something, for example, that would not be correct. So this one's true, right? Figure ABCD is similar to figure EFGH, but this is not true. ABCD is similar to FGHE. Okay? That is wrong. Okay, that's not correct. That would not be correct. The order in which you travel around the letters and the order in which you travel around the figure is important. So please keep that in mind. We've gone over that in past chapters, but I just wanted to kind of cover that again. And then also, if ratios of the corresponding side lengths are equal, then again, it's said to be similar figures. So what that means is that AB divided by EF has to equal the same value as if BC was divided by FG. So if you take this length AB and you divide it by EF, you should get the same number as if you take BC and divide it by FG. And also, that would be the same as CD divided by GH, and then also the same thing as DA divided by HE. Okay, now again, just to emphasize, these aren't, obviously, side length AB does not equal side length EF. Clearly, AB is longer than EF. But if you just take these two and divide them, you should get a certain number. Say, for example, if this is twice as long as that, for example, then BC divided by FG will be in that same ratio of 2 to 1 also. Okay? And if both of those conditions are true, then you have similar polygons. And if two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. Okay, you can write that down, copy that down. You can pause this anytime you'd like, but you will be responsible for that. And the way I will teach that concept of scale factor is through this problem. So in the diagram, polygon ABCD is similar to polygon QRST. 1. What is the scale factor of QRST to ABCD? And 2. Find the value of x. And then here are your two polygons. So please copy those down, write those down, and of course if you'd like to pause the presentation, you can do that at any time. You can pause it right now. But of course, for the sake of this presentation, I'm going to continue. So we have these two figures, and let's work on this problem first. What is the scale factor of QRST to ABCD? So here's the same two figures again, just rewritten for your convenience, and we're going to work on the scale factor. Well, the scale factor is going to be obtained by taking the ratio of corresponding sides. So we have QR is corresponding to AB. So we can either divide those two, okay, and get the scale factor, or we can do ST divided by CD and get the same number, the same scale factor as well. Or we can go QT divided by AD and we should get the same number as well. But notice that I did not say in here RS divided by BC. RS divided by BC would not help us out because we don't know how long BC is. It's just an X value. It's just a variable. So that wouldn't help us out. So that's why I only have these three written down. Okay? So to continue, we could just go either QR divided by AB, which is 6 over 12, or ST divided by CD, which is 8 over 16, or QT divided by AD, which is 5 over 10. Again, all of these will give us the same value, which is 1/2. So the scale factor between these two polygons is 1/2. And now to find the value of x, what we do is we use this proportion. We use the scale factor is equal to, well, this side divided by this side. These are proportional sides, RS and BC. And we're interested in RS and BC because we're trying to find the value of x, which is the length or the measure of BC. So that is how scale factors are used. You take the scale factor, this is the scale factor here, you take the scale factor and that will give you the proportion of all the corresponding sides. So that's where I get this proportion from. The scale factor is equal to the ratio of the corresponding side lengths. Okay, so then you just solve for that. You do that by cross multiplying. So I would take 1/2 equals 4 over x and cross multiply. And so you get 1 times x is equal to 2 times 4. And so x equals 8.